Welcome, ladies and gentlemen. So what I'd like to do now is show you how to find the focus and the directrix as well as the vertex when we have a parabola in conic section form. So just like we did in the last video where we want to determine the opening, does the graph open up, down, left, or right, that's going to be the first thing we're going to want to do in these problems as well. So, and again, that's all going to hinge on what variable is being squared. So you can see we have two conic sections forms here, one where the x is squared and then one where the y is squared. Well, when the x is squared, just like quadratics, the graph is going to open up or down. And for the y squared, that means the graph is going to be opening up to the right or to the left. So, and the first thing we want to do for all of these videos, I want to look at which variable is going to be squared. So obviously, if I expanded x minus 2 squared and I expanded out, I would have x squared. So that means this graph is going to be opening up or it's going to be opening down. OK? Now, in the previous examples, we didn't have an h and a k. And we just had, the vertex was at 0, 0. And that was, that was fine. And that kind of made it helpful and easy to find the vertex and or the focus and the directrix. But now we have some x plus and x minus, y plus and y minus. And what that represents is our h and our k, which is going to represent the vertex of our parabola. Remember, the vertex of the parabola is going to be your absolute min or max of the point. It's where kind of, that line of symmetry goes through your vertex. So that's going to be the first thing we're going to want to identify. So remember, notice in the equation, kind of like when we first started doing vertex form of quadratics, it's x minus h, x minus k. And a lot of times this might be helpful to think of these as like in parentheses on their own, because you're doing x minus the value h, y minus the value k. So why that's important is because if I was going to put these in parentheses here, you can see that h is equal to 2. H is not negative 2. H is 2. So when I'm trying to find my vertex, I'm going to have 2. And then here, well, the easiest way to write this is y minus a negative 1, right? Because y minus a negative 1, that's y minus k. Well, minus a negative 1 is the same thing as plus. So that's why it's always going to be kind of, we think about it as like the opposite. So my vertex, though, ends up being 2 comma negative 1. Now, to identify the vertex, sorry, focus and directrix in my previous video, if you remember, I plotted them. And I think plotting them is so important to just visualize and understand where exactly everything means, how it's orientated, and just so you can actually find the points as well. So you could also, if you have a problem where you actually have to graph this, just my rough sketch should be able to help you out as well. OK. So the first thing I'm going to do is, since now I have that vertex information, I'm going to plot it. So that's at positive 2, negative 1. And I label it vertex so I don't forget. Now remember, the graph either opens up or down. That's why I wrote that up there so I don't forget. The next thing we need to do is figure out the value p. Remember, p represents the distance from the vertex to the focus. If p is positive, then the graph either opens up or opens up to the right. If p is negative, the graph either opens down or opens up to the left, depending on the orientation of the parabola. So to find p, remember p is going to be your coefficient of your linear term. So my linear term here is y. My linear term over here is x. So whatever that value is, 4p is equal to it. So in this case, you can see my value is 12. So I'm going to write 4p is equal to 12. Solve for p. P is equal to 3. Now again, my graph either opens up or down. So since the value of p is 3, from my vertex, I'm going to go up 1, 2, 3. And I'm going to label that my focus. So now I know my graph opens up towards its focus, so it's going to open up to the right. But remember, the opposite of p is going to be the distance from the vertex to the directrix. So that's going to be down 3. 1, 2, 3. OK? So all we need to do for these problems is label the focus. So my focus is a coordinate point. You could easily just add 3 to the y coordinate, because you can see that the vertex and the focus lie on the axis of symmetry. So you could just add 3 to here. Or if you're having a little trouble, and just see the point. 1, 2, 1, 2. So my focus is at 2, 2. And my directrix, you could do the exact same thing. You could just subtract 3 to find the y coordinate, or just look at this and say, all right, it's down at negative 1, negative 2, negative 3, negative 4. But remember, this is a horizontal line, so it's y equals negative 4. All right? All right, in the next example, we have y plus 1 squared equals negative 16, x plus 3. So again, doing the same thing like I kind of did before, I'm going to first notice that my y is being squared in this case. So therefore, my graph either opens up to the right or opens up to the left. And again, I write that in there because so many times I've made mistakes or I've seen students make mistakes because they just forget what the opening is. Next thing we want to do is identify the vertex. Again, remember using the kind of opposite technique that I used over here. We can identify, oh, here's another thing that's really important. And I've made this mistake many times. Notice how h is with x, h is with x. It doesn't matter if it's on the right side or it's on the left side. H is always with x. So if here's my vertex, my h is over here, and here is my k. So my vertex is actually going to be at -3, -1. It's very common for students and to mix those around, and I've done it plenty of times as well. But my vertex is at -3, 1. That's very important, so I'm going to go and sketch that. -1, 2, 3, -1, and then I label it before I forget. Right? Remember, 4p is going to be the coefficient of your linear term, which is -16. So this -16 equals 4p divided by 4, divided by 4. P equals -4. Now, since p is going to be -4, that means p is going to go to the left. So from my vertex, I'm going to go left 4, 1, 2, 3, 4. And I'm going to plot that point. OK? Now, I know that my graph is going to be opening up to the left. So to the right is going to be my directrix. And again, that's going to be opposite of p. So if p is -4, opposite of p is going to be +4. So I'll go over 1, 2, 3, 4. And then I can just draw a nice little vertical line. And that's going to represent my directrix. So my focus is going to be 4 units to the left of the vertex, which is -7. Or you can just kind of count it from there if you like. So that's going to be -7. However, notice that the focus and the vertex are on the line of symmetry. Notice that the line of symmetry is perpendicular to the directrix. So my x-coordinate is going to be the same. But just remember, the directrix is a line. It's not a point. And it's a vertical line. And that vertical line is at x equals 1. All right. Next example. Now, this one can get some students confused because they see, oh, OK, well, I have this k here, but I don't have anything with the x. Well, just remember, if you're not subtracting anything, like what we did in the previous video, we could just rewrite this as x minus 0 squared. So in reality, h is going to be 0. X is squared, though, so that means the graph either opens up or down. OK? My vertex, again, h is always with x, y is always with k. So my vertex is at 0, 3. To identify my p, I'm going to have 4p is equal to a -10. So now I need to solve for 4. So I divide by, or solve for p. So I divide by 4. And I get p equals -10 over 4, which can be reduced, divide by 2. P equals a -5/2. Not very fun, is it? OK, so the graph, though, however, either opens up or it opens down. So let's plot that information. I should have done it over there. That would have been nice of me. OK. So I have -5, 0, 3. So that's going to be up, 1, 2, 3. There's my vertex. My focus is negative, so that means the graph is going to be opening down, and it's going to be down -5/2. Now, you could always convert that to a decimal. I don't like decimals, and I don't like mixed numbers. So I like leaving things as fractions. But as far as conceptualizing and understanding the value of that fraction, looking at the decimal form might be able to help you. However, I noticed that this is exactly -2.5. So when I'm sketching that, I know I'm going to go down 2 and then half on the other one. So that's going to be my new focus. And then to go up, I'm going to go up to 1, 2, up 2.5, which is now my, that's not a line. That's my directrix. Now, again, the graph either opens up or down, since it's going down to my focus. OK? And then I can go up is going to be my directrix. Now, as far as finding the values, you should know how to add and subtract fractions. I would stay away from decimals as well as mixed numbers. But this one actually really isn't that bad. If I convert that to a decimal format, you can see that my vertex is 0, 3. You can see I'm going down -2.5, which is just going to leave me with 0.5. However, as I mentioned, I don't like dealing with decimals, so I'm going to write it in fractional form. My directrix is a horizontal line, so that's going to be y equals. And again, that's going to be going up 1, 2, so 1, 2, 3, 4, 5. So it's going to be 5.5 roughly. And your teacher might accept it. Depends on what kind of mood they're in or what their expectation are. But basically what I would do is, let's see, if I'd have 3. So if I did 3 plus 5/2, and that gives me 6, so that's 6 over 2 plus 5 over 2. I would prefer it to be y equals 11/2. But both of them technically are exactly the same. All right, in the last example, a lot of students will just say, I'm not even going to do it because it has fractions, right? But this one's actually easier than the last example, even though you see the fractions. And I'll show it to you. Again, we see that y is squared, so I know my graph is going to open up to the right, or it's going to open up to the left. However, finding 4p sometimes gets a little difficult, because in all of these, we always had a number that was in front of my linear term. In this case, I don't have a number that's in front of my linear term. However, just like I kind of did in that first example, we could always put parentheses kind of like around there to understand that 4p is going to be equal to 1. So I do 4p is equal to 1, divide by 4, and I get p equals 1/4. Now, since the graph opens up to the left or right, we see that p is positive, so I know my graph is going to open up to the right. My vertex. I need to identify my vertex. So my vertex is my hk, so that's going to be 3, negative 3/4. And again, negative 3/4, when you're plotting this, doesn't need to be exact. Just know that it's not all the way down to -1. So I'm going to go over 3, 1, 2, 3, and then down 3/4. So there's my my vertex. Now again, remember that the graph is opening up to the right. So the graph is going to open it to the right. And how far is it open? How far is the focus? The focus is only 1/4 over. So I'll just do another tick, and I'll say, all right, well, here's the focus, right? Like right there, really close. And then I got to go to the left 1/4 to get my directrix. So the graph is going to look something like that, 1/4 to the right, 1/4 to the left. However, to find the point, though, wait a minute. Oh, I did mess that up. Dang it, I was supposed to be doing the other ones. Well, that's OK. We'll just add some more fractions. I was hoping to do it to the y coordinate, but the graph opens to the right or left, so we're going to be doing it to the x coordinate, so it's not going to matter. Anyways, we can still figure this out. So my focus is basically going to be 3 plus 1/4, negative 3/4. And my directrix is basically going to be x equals 3 minus 1/4, right? And again, you could use, you could do 3.25 and negative or 2.75 as decimal equivalents, using 1/4 as 0.25. I just really don't like doing that. I think you should know your fraction operations. We could easily change 3 with a denominator 4 by multiplying by 4 over 4 to give me 12/4, which is equivalent to 3, plus 1/4 equals 13/4. So I could rewrite this as 13/4, negative 3/4. And same thing for this. I could rewrite that as 12/4 minus 1/4. So I could rewrite this as x equals negative 11/4. OK? But either way, the main thing I think of this video is making sure a lot of times when you don't see it, there's going to be a 1 in front of there. So there you go, ladies and gentlemen. That is how you determine the focus and the directrix, as well as the vertex, when given a conic section, a parabola in conic section form. Thanks.